All right, everyone, I'm going to test the voice and the video. Please let me know whether you can hear me or not. Hi, Nikki, how are you? Welcome here. This is my first time doing streaming, so I will have some technical difficulty. Please let me know if you cannot hear me or internet is not, slow. It is slow, and then I will try to fix it. Okay. So let's wait for a couple minutes to have more people join before I can start it. Can people hear me fine? Can you let me know in the chat? Okay, great. That's a good news. All right. Maybe we can introduce each other, maybe say, where are you from? And then why you want to learn Solidity. And then we all know that blockchain brings so much opportunity here. So today I'm going to help all of us to walk through the CryptoZombie, which is a killer course to learn Solidity programming. I think my chats didn't update very well. Hi, Jaime, how are you? Good to see you here. It's weird to do streaming, okay? Bear me. All right. Awesome. I think I will go ahead and start it. For people who come early on time, thank you so much. It's early in the morning, a.m. here in Arizona. And then I hope you have a great day, after go through this with us together. All right, let's dive in. So there's a big news. Hey, we're gonna have to build. We're gonna have a product called CryptoZombie, right? So it's a fun game, and this a game. You're gonna have a multiplayer battle on the zombies, and then also very important, you can become a global top players. And also, the assets inside of that can be traded with each other. And this is called zombie as crypto assets. So when you tell the story to the customers and customers say, hey, wow, where can I play with that? Yeah, our MVP will be available in next 4 weeks. So you go back to your team and you ask your team, hey team, we need to build the CryptoZombie game in the next 3 weeks. And can you imagine that what the team gonna answer? Team gonna say that, hey, what the heck is a CryptoZombie game, right? And then 3 weeks, impossible. Wait, we're gonna go through together this course. We're gonna see how we can create a CryptoZombie in the next 3 weeks together. So my name is Hui. This is my personal dev channel called Skylight Dev Channel, and welcome here. And in the next 3 weeks, we're gonna go through CryptoZombie coding challenges together. In today's session, we're gonna just simply go through 3 parts. Number 1, we're gonna first understand that what is the zombie game requirement, right? Everything starts with what the business try to achieve, where you want to bring this product, the idea. The second one, we're gonna dive into the packed one. We call making the zombie factory, because without the zombie in your game, it doesn't work. So you have to somehow code the factory, the piece of logic, so that you have this zombie factory. And the second one, we're gonna add complexity into the game, which is the zombie you created can interact with others, which is in this particular scenario is attacked victims. Because the pack 1 and the pack 2, we're going to today walk through that so you can have a very basic, logic that is built into your game. Just want to double check, is everything okay so far? Please let me know. Did you have any problem hearing me? And everything's fine? Hi, Frederick. Mario from DLT. Yeah, we have many DLT friends here. Hi, Annie. Welcome here. Yes, we have Mary from DLT too. Awesome. All right, we're going to go back. So even we're learning how to code smart contract, right? So this is a very niche programming, area we call smart contract programming. And then inside of that, there's many blockchain who can offer smart contract programming. So today we're going to focus on Ethereum because Ethereum so far has won a lot of the developers. It's the first, and then the current smart contract platform. And then the language we're going to learn today is really focused on Solidity. But keeping in mind here is when we talk about programming in general, there is multiple areas for programming. For example, when you're in the school, you probably learn something like C#, Java. Those are general programming or object-oriented programming. And later on, if you join into the bootcamp will teach you how to build the modern web programming. So which is very target because the goal is to build a web application or mobile application. Now today, we're really talking about DApp. So D represents decentralized application. So whenever you heard about DApp, what it really implies is a set of the components in the system when you try to use programming language to construct your logic, construct your data structure. In this particular case, we're going to pick whatever the popular front end. So front end is think about the web application today. They will have a front end, they will have a back end. So DApp architecture will simply have this front end, which is the front end codes can directly go to the internet to talk with the blockchain. And then blockchain, you may already know that it's a very unique architecture, which is kind of like a peer-to-peer computing network. So this is very, very unique because nobody gonna owns this network. It's kind of a collective. We all can contribute our computers and join the network. And also blockchain has a unique data structure, which is called distributed DLT or maybe chain structure like the blocks. Besides that, Ethereum has done excellent job by introducing the codes to be run on the blockchain. So that's why we can implement contracts. So you can see that we don't call logic here, we call contracts. So we're gonna truly understand that. What does that mean? The contracts as a logic, which is the contracts today in the real world, and how does the contracts actually manifest on the blockchain, which is in the machine world. So that is kind of a simple architecture you can have in the mind. When people ask you what is DApp, you can very confidently let them know the front end, the blockchain. But keep in mind here, right? There's many options. People are trying to solve different technology challenges, which is involve different concerns. So for us, if you're interested in building the application level, so you just need to ask yourself, what's the application you are interested to build, and then whether the blockchain is actually suitable for your case. So that's kind of a high level, when you talk to any engineer or people who can understand the tech to make the decision together. Okay, so a simple claim here. Today, what I show you guys, I call that experiential learning, right? So the key is I'm going to use the use case, which is already being designed, called CryptoZombie course. So you can see that this is very popular in programming learning because people need a use case so that they can actually kind of like you watch certain chef or Like you go to the YouTube, right? You watch certain people who cook like pancakes, so they actually, it's a showcase to let you know how does that from raw materials, and then you understand it, and then you do one kind of problem solving all together through that experience. So this is called experiential learning. But let's don't confuse ourselves. Experiential learning, like you watch a couple YouTubes, right? Like, hey, we all do that all the time. But it doesn't mean that you actually acquire the true knowledge. So you have to use other means to supplement your learning. So if you really want to become a D app developer or be the top, the person who can speak around what is the best to code the smart contracts, you need to do by yourself and then practice a lot. And in this journey, you're going to ask yourself why you make these decisions, and what decisions can be made through the programming, and how do you evaluate that and optimize that. So this is typical developer thinking path, which is whether today I have this Solidity I have to learn. Maybe tomorrow I have to learn totally new language, right? Who knows? So that's kind of a mindset you need to keep in mind. But if you said that way, I just want to learn enough so I can talk to the developers. So I think this course is also help you to understand how you think through the problem and actually tackle that. All right, let me go back to the chats to see, is anybody have any questions? So far is hi everyone. Hi Victoria. Hi Vishvasha. Hi Kuala. If I don't spell your name correctly, please forgive me, okay? But feel free to social in the chats. And of course, we're gonna do social in the DLT group as well. But anyway, let's go back because time passed so fast. Okay. So remember, we already tell the market, right? We tell the market, say, hey, our MVP will be available in 4 weeks. And we said that why this CryptoZombie game is so popular. And then here's a couple kinds of value propositions or benefit you tell the customers so that you get them interest. And I can tell you, whether you are developer or not developer, if you cannot describe why you need to build a game, what is the benefit about your app, you just you don't know where to shoot. Okay, so this is very important, is to tell your product story. Okay, so once you tell your product story, typically come from the visionary or founder, or people who have this idea. But then you need to tell your team, right? So we're in the journey about tell your team. Say, hey team, we need to build this. And team got confused because just the story is not enough. You need something called requirement. Okay? So, and this is the key because engineers need a little bit more details so that they can understand that what are the things in the scope and how to smartly prioritize those features. And this is the right place to debate. Okay, so don't be afraid about, you tell the good story to your market, which is the external message, but you also have to do a good job about inspire your team to actually connect with you, to understand that why this zombie game is, we need to build it. And then what are the important things we need to flush out, right, about this. So I give you 3 simple framework. And then having this in the mind, then you go through the course, and then you can kind of understand it. I mean, it's easy to go through the course by follow step by step, kind of like IKEA, right? Like you follow step by step. But if I throw you a brand new open problem, and then how do you solve it? That's the key. Okay, so let's bear in the mind about, imagine there's no course, it's just some Spark, right? And then how do you get to the next level, which is come up with the details? So 3 things. You have to describe the purpose. Without the purpose, everyone can come up with the ideas, which is shoot everywhere, right? So you come up with the purpose. What is the app for? And who you build this app, which is the audience. And then how they address today. So those are called context and then called purpose. If you have those, that give you a very good foundation to talk with the people. And for engineers, they need to understand that what the functionalities you really introduce into system. So you have to somehow help them to bridge from what you want, why we want to do this, to what are necessary needed. So what the app can do, right? So when we talk about functionality to engineers, they care about that. They say, Hui, what is the functionalities? Just tell me the feature 1, 2, 3, 4, right? So you just kind of have to list them out, describe those features, and imagine you are the user, how you kind of interact with the system. And another important thing is called data. So what data matters here? So you have to think about the information in this whole system. And this is a functionality view. This is data view. And then how does data going to help you users, decision makers? Because data kind of like an important sort of information, which is guides machine, guides user to machine, machine to machine interactions. Okay, so I've got so far the preparation and then the foundation. Is everything okay with this idea about how to understand the zombie game requirements? Okay, let me go back to that. Any questions so far? Everything's fine. Thank you for letting me know that. I'm so nervous about doing my first live stream. I hope I can deliver good energy today and you will be inspired and later on join smart contract, development. Awesome. Yes, I think YouTube will have this recording, although I did not, I think the YouTube will get that video as well, so you can replay, right? So that's why we go to YouTube. So if everything's okay, we don't have a lot of time, right? Because it's too late in your guys. So we're gonna deep dive, okay? So if you want, you can open the course as well, but make sure you also have a separate screen. You can see how I actually interact with the course. Okay, so let's go through the course, okay? So first one called Making the Zombie Factory. So by the way, the Loom Network actually did an excellent job. So that's why this course has gained the #1 popularity, because they designed this learning journey in a fun way, which is I super love it. Let's see how we do that. Everybody knows zombie, right? Okay, come on. Yes. Okay. So in this particular game, this is text. So first we need to be familiar with the environment. Okay, so this is text, which is they let you know a little bit of knowledge, and then the problem domain we're solving, and then there is a test section, which is you need to do the work. You need to interact with this the course. And the programming learning is very important. Okay, that means you have to do a lot of the interaction with a course. So the better course is you learn one thing, you try it, and then you learn another thing, you try it. Okay, back to here. So this gives you how does the crypto zombie look like, right? And then you can look here, it's called crypto collectibles. So you can kind of understand that it looks like a Pokemon card. And then our job is to manufacture a crypto zombie. And then here's the first concept, which is this course introduced. It's called CryptoZombie DNA. Okay. Why? Think about this, right? In this game, we want to introduce uniqueness. So every zombie you're gonna create it, you want it to have a DNA. So think about DNA, it's just an attribute, right? And for the sake of the simplicity, so this game actually says that you can use 6-digit integer, and don't ask me why. Okay, this is just like let's give an attribute. Okay, as long as it's unique. So somehow they pick 6-digit integer and represent this. Okay, so this is a DNA code, but DNA code is different than this, right? And then you can say, what the heck is this? So this is really say they have introduced 1, 2, 3, 4, 5, 6. They introduced 6 attributes so that they can represent zombie appearance. Okay, so there's another concept here called zombie appearance. So right here, if you read this paragraph, what it's trying to let you know here is in this program, we have to somehow randomly using random generator, which can generate this random number. Okay, think about the machine has this little secret power. We can generate random number, and how does random number gonna translate into 6 attributes of appearance? If we can translate that successfully, that means we can map it, right? So, okay, we can map it. You can see, and then it will be correlate to this appearance in a graphical way. So basically, that's what this paragraph trying to let you know is how does this information data be connect with 2 concepts, one called DNA, another called appearance, and then you can use some math, right? So computer science, very, very important, connect with the math. So it introduced this operator, and this operator gonna figure out they're gonna use 2-digit, right? So they said that if this first 2-digit if we use the math, and then somehow we can figure out an option between 1 to 7, right? Because they have 7 options. So that's how they use the programming to connect the dots which is in the real world. You have 2 concepts. You have to translate the program. Okay, so let's go ahead and play with that. So you already played with this. Okay, any questions so far? I just want to be slow at the very beginning, okay? Okay, all clear. Thank you. Let's go. So first, we're going to understand syntax, right? Called contracts. Oh, I just remember. Before we go through this, remember requirement? Okay, so I need to get this into your head first. So in this packed one, we're going to talk about making zombie factory. And if you are the business person who brings the requirements, so here's the 5 requirements. Let's keep in mind. First one called zombie needs to have a name and DNA. You got it? So we just have 2 attributes to describe zombie. So you can think about it as a zombie.name, zombie.DNA. Okay? The second one called zombie's appearance can be derived from its DNA. So I just described it, right? How do you have the DNA, which is go through certain kind of the math computation, and somehow you figure out each value for 6 attributes of the appearance. So that's second requirement. And third requirement is we need to create something called zombie factory. I don't know in your life you actually create a zombie factory, but just think about it. You are the chef. You're gonna make many pancakes, right? But instead of you make every day, you're gonna build the machine, and the machine can automatically make pancakes. so that's kind of a simple analogy here. Is that we're gonna make a machine that can, with a 1 click, you can call it to create a zombie. And the fourth is anyone can see the inventory of the zombie factory, which is the data part, right? So you can call it, but hey, I want to see how many zombies you created. Is there any way I can see it? So you better do bookkeeping. You better track it, which is the data concerns. And the 5th one is called notify me if there is a zombie is created, and this is called event. Okay. So if you have that, this is all this pack 1. We're gonna go through that in 30 minutes very quickly, and you don't have to worry about it. All notes were gonna be available. But this is just kind of a highlights. We go through that. Back to course. Contracts. Okay. So Solidity is all about contract. So we have to start with the contract. Think about the contract like if you're learning other programming language, you're probably familiar with the class. Okay. So in order to tell the programming, like Ethereum, you have to start with contract, right? So the contract has to be the keyword, which is some compiler. When I use the term compiler, I'm so sorry, my cat wants to go out. So forgive me, I need to open the door for her and I'll come back, okay? All right, I'm back. Everything's okay? Okay. All right, contract. So this is a contract syntax, right? So let's build a contract called hello world, right? So you can do actually like this. So let me explain something quickly. Contract is a keyword, and this is your contract name. And then look at here, there's some convention. So convention is very important when you do programming, okay? So it starts with the first letter character, capital, and second capital, and without space, without any other stuff, okay? So you just come up with very friendly name, so people know that what's this contract. Next concept is called version, okay? So why we have to specify this? Because you have to tell Solidity engine so that they can somehow read whatever you coded and then they can understand it. And then because of Solidity library, we'll have a version going on. So you have to tell that which version this piece of code is compatible with, right? So this is kind of the syntax. You can go through that, which is what I try to say here is I want to make sure you can use Solidity engine or compiler that is greater than the version called 0.5.0, but less than this version. Okay? You can see that, when doing the programming, and then machine is actually not very smart, right? Because you always ask us. Hopefully, in the future, we don't code this way, but right now you have to somehow balance about explicit programming and implicit. So here's a test. In the box, right, we have to specify this. So you just replace this and simply do this, okay? So if you do this, right, it looks good. Let's just give it a try and give you the error, right? So this is called debugging. And by the way, probably 60% of your programming life is battle with debugging. So you have to understand the error. Unfortunately, this does not give enough error message, so you kind of have to guess it, right? So go back to the course and see what are things are missing. So in this particular case, we're missing something called semicolon. So semicolon is very important in theorem. So in the Solidity language syntax. So make sure you always have a semicolon. So try it again. Okay, so yeah, see here, we don't want a hello world, right? Based on the task requirement, we want something called zombie factory. So you have to do this. So I'm showing you this all possible errors, just trying to kind of give you ideas when you do the real exercise by yourself, what could be the things can go wrong, right? Okay, perfect. We have gone through the first one. Second one. So now you understand the contract. Now you understand how to tell the Solidity which compiler version you're going to use it. Now we are going to introduce something called state variable. Okay? So state variables, so ideas here is in programming, sometimes we have to store data. And then in this particular case, data is represented by data type. So you can see we always start with the data type, and then data variable name, and then some default value, right? So if you already know how to programming, this is no-brainer because it's very similar. But if this is your first time know about programming, you kind of have to understand this, okay? So let's see what we're trying to do here. Okay, so the first data type we're gonna learn is called unassigned integers. So integers in the computer science has a multiple different representation because they represent different range of the integer. So you can see that you have integer of 256, integer of the 8, integer of the 16-bit, integer of the, bytes, integer of the 32. So those just represent how large the range of your integer you want to assign, you want to give this variable, right? So the default one is called int, which is represent to 256. And then u represent unassigned. And then right here, you can see that it represents the value must be non-negative. Okay? So this is just understand the syntax. Let's see what's the assignment trying to do. So here we wanted to declare a variable called DNA digits, right? Okay. So if you start with this, keep in mind, what is this? This is the variable. But remember, always start with the type first. So you say uint type variable equal to 16. Okay? Isn't that simple? Yeah, but it's simple when you do one by one, but also you need to later on combine them together, okay? All right, let's move on. So in this chapter, we're going to talk about math. So now we already know how to declare the variable, give the default. So this is just the math, right? Similar like the Excel spreadsheet. So plus, subtraction, multiply, division, modulus, which is figure out the remainder part, and then power, right? This is called exponential operation. Okay, so remember our business requirement, we need to have a DNA, right? Zombie DNA. So we need to, we need to have a zombie DNA, which is generated from the random thing, but we also need to have that appearance stuff. So just follow this instruction to see how we can do this step. So you introduce another variable, okay? And then you say that, hey, this must be 10 to the powers of this number, right? To this variable. So remember how to do power? This is how to do power. And then of this number. So this is called refer, right? Refer to another variable. Okay. All right. Is everything good so far? Let me just double check. So you can only watch. Okay. Okay, not bad. Let me move on. Okay. Here we're going to talk about structure. Oh, sorry, not structure, struct, okay? So think about the struct is kind of a compound, right? Data type, which can hold multiple variables. So in this example here, he tried to describe a data type called struct, which is person, and it has two variables, two attributes for that. So we're going to do the same because we need to represent that zombie, right? So let's say struct, remember data type first, zombie, curly brace, and you just put the two property, right? So start with the data type, name, uint, DNA. Look that again, trying to make sure you understand the structure. Everything looks good. Okay, so that's how you define the structure. So once you have the structure, now we're going to talk about a new data type called arrays. So think about the arrays as a collection of something, right, or list, because we're not just creating one zombie. We'll have to create multiple zombies. Remember that inventory idea? So we need to represent that. So in this particular case, this is the example how do you represent. So the syntax look like you have to specify, what is the element, what is the data type for the one element inside of that list, and you use this square bracelet, and then you have this this is called scope, right? It's a public, which is you can outsider can access to that. So in this particular case, we're going to create a public array of zombies structures list and a name as this variable. So let's see how we tackle that, right? So follow this example. We're going to say zombie as an element data type. You give this and then say, hey, that's my inventory name called zombies, right? Don't forget put the semicolon. Oh, let's see what happened. Oh yeah, did you know that? I forgot to put a public. So make sure you put a public. Bingo, we got it. Okay, any questions about structure? Okay, everything's good. Back to here. So let's review the code again. We have known how to do integers. We also know how to do struct. We also know how to declare a variable. So now let's get into the most fun part, which is called create a function, right? So here's a function syntax. Function syntax start with the function because you always start with something to indicate that. And then you have what this function name. Pay attention to their naming convention. And then in this bracelet, you can see that it's called parameters. So, and then you have this visibility scope, whether it's a public or private. So that's kind of the ideas about function. Okay. There's a very important thing for if you learn any kinds of programming language, it always touches functions. And when it specifies the function, there's two important concepts called parameter, whether parameter when passing by value or parameter passed by reference. Okay, so think about this way, right? You declare the function, and outside you can call this function. When you call this function, you have to provide parameters. So in this declarative way, you can let people know whether you expect when the parameter by passing to that, you have to tell the machine says that, hey, I want you to literally create a copy, right? A copy of the parameter when they do the mapping. So this is called by value. Or you said that, no, I don't want to create a new copy. I just want to create please use the original, value, which is outsider, I pass on, right? Which is called by reference. So that's kind of a two important concept. You have to grasp it, okay? Another very important here, you have to kind of read it to understand it, but the idea here is naming convention. So if it's a private variable, Solidity programming suggests that it always starts with underscore, right? So that's kind of a private function. Okay, let's go ahead and create a public function. So we're going to always start with a function. We said that the function name is called CryptoZombie. Okay, and then it takes parameters. So the first parameter is start with data type underscore name, and another one called uint underscore data name. And then remember the first parameter. So here they suggest that using the memory, which is say that, hey, I don't want it to use by value for that parameter mapping. I want to use by reference. So the memory just tell the Ethereum don't store it, right? When you do the call the function, please do not store a variable, make a storage in the blockchain, about that parameter. Okay, so that's how you create a function. Let's see, is there anything we're missing? Yes, we're missing visibility scope. So you put a public as a visibility scope. Okay, everything looks good. Nice. By the way, is that the screen too small? Is everything's okay? Okay, let me see the review. Okay, what is public function? Great question. Let's go back. Okay. So, where am I? I need to go to function. Yes. So if you already understand the function, right? So the function is kind of like a place you can encode encode a little bit sophisticated logic, but outside can call your function. And when we say public function, what it really says that the caller, which is outside of this contract, which can be another contract, or it can be the D app, right? So the caller can actually interact with the function you just created. So if you don't specify the function as a public, or you can specify as a private, that means outsider cannot call this function. Only inside of this contract, other functions can call your function. So this is really control the scope, who can call your function. So that's why you have to explicit specify that this is a public, this is a private, and in the down the road, we're going to learn two more additional scope indicator. They call internal functions and external function. But just think about very simple, right? You let other people know, because this is kind of like a interface or specification. You let the people know who can call me, right? So if you specify public, means others can call you. Oh, it's kind of small? Okay. All right, make it bigger. Sorry about that. Is that better? Awesome. Yeah. Okay, let's move on. Yeah, if I do this, this might be better. Okay, because otherwise I cannot read the text properly. That feels ugly. Give me 1 second. Let me just change my view a little bit, okay? Yes, a lot better. Okay, sorry about guys. That's another thing I learned today. All right. Okay, so in this chapter, right, we're gonna remember we already create a function. Now let's figure out what inside of the function body. So this is called, you can think about this as a kind of a function interface, and this is called function body. So our mission here is to put a more logic, right? So what is the CryptoZombie function? In the CryptoZombie function, we need to somehow assign the value to this zombie, and then later on put into the zombie class, the zombie array. Okay, so let's see what the syntax we're going to learn here. So over here, first you need to learn two things. One is called how do you create a struct variable which has actual value. So you can see this is how you actually assign the value, and then through this kinds of we call that constructor, and then assign to a variable, which is you have successfully declared a variable that is for that data type. The second thing here is you're going to use push function. So the push allows you to, by giving a variable, which is then you can append it into the array. And then you can write the code with these 2 lines of codes, or you can somehow embed it, right? This is called one-line code, which is, think about you're lazy about introduce a variable. Let me just kind of inside of that call it. You just like placeholder. So instead of introduce the variable, you just directly copy paste and then replace over here, which is become a one-line code. Okay, so let's see how we can do the same thing for our zombie array. So let me do the first version first. Okay, so the first version is how do I create a one zombie first? So you say, hey, I want to have data type zombie, lowercase variable zombie as a variable, and then you say zombie, right? Then you start to give a parameter. Remember the parameter? So function already have a parameter. You just need to pass on, right? So you just say, hey, I'm gonna pass on this 2 parameter, and you're gonna over here. This is how you create a zombie, one single zombie object. Okay, and remember the push function, right? So you're gonna say that, hey, my array list dot push, which is this is how you trigger the function. And then you say that which one object element I wanted to push into the array, which is you give that parameter. So actually, these 2 lines of code already successfully implement what they asked for. But they also asked for us to do 1 line of code, right? Because sometimes 1 line of code make the easy read. So we just need to do replace this and put over here. And clean up a little bit. So let's read this line again, right? List. So we need to call the push function by giving it a 1 element called zombie. All right, we did it. Let's go back to the, any questions so far? How do I know which bracket to use? Okay, great. Again, there's no, don't overthink it, okay? It's just like convention or whatever the language creator trying to introduce. So for function, you need to use curly. You just memorize it right on your cheat sheet, okay? Struct is curly, okay? Function is this kind of a parenthesis, right? And the array, remember array is this square. So just memorize it. There's no deeper why. Whatever the language creator, they have preference, but typically through the whole programming history, people kind of like settle down the typical options here. Any other questions? Okay. Okay, more on the function. So now you know function interface. Now you know some things you can code inside of that called function body. Now we're going to introduce something called return value. Okay. So function, besides you can tell the function to do like 1 line, like step 1, 2, 3, 4, function also has something you can return. Okay. I will kind of connect the dots later on. What is return? Because return means you can say, hey, after you finish all of the logic inside of that, please return a value for me. So the caller actually not only can trigger this function, but also can get the internal variables value out of the function. Okay, so let's follow the simple example here. So they have a function called say hello. It's a public function, means outsider can call it. And then we want this function to return a beautiful string called what's not beautiful, it's just string, right? What's up, dog? Greeting. So what you need to do is just add this simple syntax here. So let's decouple this. So you have to start with the returns, and it returns inside of that, having this kinds of a list of the parameters, which is the values you're going to return. So it looks super simple. So that's the return. Besides the return, in this chapter, they also want you to learn another concept called function modifier. Okay? So what is function modifier, which is you can put on that? Remember the visibility scope? I talk about it? Yeah. So public private, it's 1 dimension, 1 policy, which is you tell the function whether outsider can call it or not call it, right? But there's another thing called view, which is called modifier. So they add additional dimension, which is you can specify the function. So if you add a view to this function, you basically like trying to let outsider know this is a view function. The data inside of that you cannot, the data you can only view the data but cannot modify the data. Okay. And then you may wonder that it's already there, right? Like you call the function because you're already inside of that. You don't have a much more control to change the variable about that. But look at here, we're using some memory string, right? Maybe there's a parameter during the interface level you have to pass on. So you wanted to kind of at the 1 interface level to make the agreement. Kinds of a caller with the function to make agreements. say, hey, I don't want any data to be modified, inside of this function. So that is called view. Then you have another modifier called pure, okay, which means that you are not even access any data in the app. So that's it. That's even kinds of more constraint on that. And you may wonder that when should I need to think about those modifiers? I think at the very beginning, you don't have to think about it. You can just start with the public and private as your first concern. And then later on, when you do double check, right? Like you try to optimize the codes you created, and then you can start to ask yourself the question. And then often, if there's a good kinds of a coding environment, which is we call IDE, people who build the software to help the developers to code intelligently, sometimes they will suggest you whether this function they have a security hole or not. So you don't have to memorize all the time, but it just like it really like depends on the coding environment, how intelligent they are, so that they can automatically suggest you. If the coding environment is not intelligent enough, you have to rely on your cheat sheet, right? Or rely on your brain. So that's the case. Okay, I think we need to go a little bit fast. So let's just make sure we know how to do this session here, okay? So in this particular test, we need to create a private function called this. Remember, the private function always start with the underscore, okay? Let's give a try to see how we're gonna code it this way. So function underscore generate random DNA. Okay, so function take parameters, so they're giving us the instruction. So you say data type underscore string, which is the variable. Okay, only one parameter. And they want you to return. Remember the return syntax? So you have to say returns, parentheses, and given the what the value and data type you want to return, right? So they want you to return an integer, unassigned integer. So you just simply say that uint. And you can see here in this particular case, you don't have to specify a return variable name, right? You don't have to do that. So you just simply specify the data type. That will be enough. Okay. So we got this to be done, and they said that don't forget about putting the memory. Okay, let's put in the memory so that it's by reference. Okay, so the function will view some of the contrast variable but not modify them. Got it. So we have to put as view. Remember, I forgot to put the public, right? But it's a private. Yes. See, sometimes you just forget about it. Okay, so function body should be empty at this point. So that's how we create this private function so far. All right. Any questions we have today so far? Push value. Okay, great. You guys helping each other. That's the whole point. All right. In this chapter, we will continue finishing this. How can I generate a random DNA? Remember the business context we talked about? Finally, we come to the random generation. Okay. So Ethereum has this native function called this. Okay. And just think about this is Ethereum already provides that function, so that's why we call native function, and this is called hash function. So hash is a cryptographic algorithm. This algorithm has a special code called SHA, right? SHA-3. But any hash function can do one thing very well, which is they say, hey, give me your input. I'm gonna create the like secret cipher, code out of that, right? So somehow they will return the output as a 256-bit hexadecimal number. And you may not wonder that what the heck, the hexadecimal decimal number. So it just look like something look like this. Okay. All we matters is there's some input, which is you can give the string, and somehow successfully using this standard hash algorithm, and then you get this output. So let's see how we can use this to take the string and return the hash. Okay. So here's a very interesting note here. Random number generation in the blockchain is very important. So he mentioned that about that is right now, because we want to represent the variable called zombie DNA, right? Say, hey, we wanted to use this random number, somehow give me any arbitrary number so it can store the value. But this paragraph trying to let you know here is this random generation number is really, how to say this, is a very serious computer science problem solving. Because in order to have a truly random, that's why people in the computer science domain have to come up with all sorts of algorithms to kind of give you that return value, right? But it's a hard problem to solve, and then that's why you heard about like blockchain today, who can generate this random private key, public address, all through this cryptographic algorithms. Right here, we're talking about typecasting. So they're introducing another new concept. Typecasting is used when you have the two different data types. For example, in this particular case, you have the data type that is U integer. Remember, U integer is a 32, right? 32 bytes of the integer, which is you wanted to turn into the 8. Okay? So in order to do that, the typecasting, you have to explicit, kind of like the function. So you put the type in front of that. You say that, hey, B is this type, but I wanted to force it to convert it to another type. So that's how the syntax actually works. Okay, so let's see what this instruction right here, how we can finish our challenge. So he wants us to somehow generate a variable called random. Okay, so we're going to specify rand. And we're going to say that this is equal to the hash function. We're going to use this. Okay, so we put this. And then we say, just follow the example. How does this look like? Okay. So let's read this line again. So this line is, we're going to call this hash function. This hash function somehow will take this string and then go through another intermediate step, which is encode the path. And then it can successfully generate that hash, right? And remember the hash return. So hash return is something that may not be compatible about this data type. So we have to do typecasting. So you have to put something like this. Okay? So typecasting, whatever the return value, the hash, we're going to make sure it generates the 16-digit of random number, which is that random number we're going to use to do the DNA, right? So once you have it, then we said that our DNA is 6 digits. So you have to do return. Okay, so we're going to say return. Okay, so here's a little bit of math here. Because our value, which is the DNA, right? So forget about this. So imagine you have a variable called DNA. Somehow, we like to use this math. The math can figure out the remainder part, which is this may generate longer digit, right? But we only need a 16. So that's how they use this math to get the 16 digit. Okay, because in this particular case, we don't want to use, we just want to return. So you put a return. We probably need to put a parenthesis. Let's try without the parenthesis first. Okay, so we have something. Okay, maybe I'm missing some parameter. Yes, I do missing one parameter. Okay, try again. Oh, that works. Okay, so that's how you create a random DNA. Let me go back to the chat to see if people have any questions. No? Okay. Feel free to ask questions, okay? Okay, we're almost done with this. So let's go into chapter 12. Again, let's review the code, right? Too many things have going on. Do we still remember our goal to create a zombie factory? So let's go over that again. We learn how to introduce two integer variables. Here's our struct, which is have attributes to represent the zombie. Here's our array, which is we like to store a list of the zombies. Then we start with the two functions. This function start with underscore, kind of let us know this is a private, but this is even stronger indicator because you have to explicitly say this is private. So functions always can take variables, which is the parameters. So in these parameters, you can see here, we also learn how to use the push function, which is you can create an object and then append to the array. Here we also learn how to call Ethereum native function, which is called this, to generate a random integer. Based on the random integer, we somehow wrap it in this function. Look here, the function called generate random DNA, right? So the idea here is, hey, give me any string. I'm gonna call this magic body code and then return a DNA for you. Okay, so that's so far we have it. Okay, so now they want us to do a little bit changes. So we have to create another public function. So let's just do that. So we say function, we call create random zombie, and then it take parameter. So first parameter string, memory, name. Is there any second parameter? No. Okay. So in this particular case, we want a public function. So you have to call it as a public. Okay. First line of the function, run this. Okay, so now we're connecting dots now, right? So we're gonna call the other function we just declare. So how to call it? Very simple. You just specify the name of the function. And then you pass on the actual value. So in this particular case, we want to pass on this value to this function. So, and remember that, right? Those are like, this value going to pass on to this function, which is, you can see over here. Okay, so we call this function, but we like to get a return value to store into this another variable. So this is what we're going to do. So we said that, hey, we're going to have a return variable called random DNA. And then it basically equal to the return value it just called. Don't forget put the semicolon. Sometimes you will get an error because of a semicolon. So that would be the first line. So the second line here should run the CryptoZombie function by passing another one. So it's the same thing, right? So no big deal. Let's call the other function. So you give the function name and you say, hey, what's the variables I should pass on? Remember the variable? You need to give me the first parameter, the name, second parameter of DNA. Got it. So the first parameter is the name, which is I can get from here. And second parameter is the DNA, which is I just I just store it over here, right? So that's how the things are like connect to each other by calling another function. All right, so now I have this code. So this function is that's the only public function right now, which is inside of this public function, you can call the other two private functions. You just call it. And this is how that works. And you may wonder that why we need to like come up with 3 functions. Can we have a one logic, right? Like just copy paste every piece of the steps inside of the one big? The answer is yes. You can code that way, but often this is something called refactory. So the idea is to introduce multiple functions, is to make those functions can do one little things better. So each function can be reused into the multiple cases. So that's, you have to kind of put this logic in the one function instead of having this logic line to be a very long function. Okay, so if you're a senior developer and you have code many times, you kind of understand that how you move around those logics so that it can be very reusable. All right, so I think we accomplished this. Chapter 12. Okay, we're almost down for the pack 1 now. So let me go back to here. Any questions? Everyone is still there? Okay. Okay, so we're going to talk about event. So what is event? Think about the event like app notification, right? So like it doesn't do anything. It just raise the message so that so the people who like caller will kind of subscribe that message. So that's how you can do inside of the function. So the caller can say that, hey, function, please do this A, B, C, D, E for me. So that's a function can do. But at the end of that, function can say that, hey, I finished my job. So that will be the event, right? So we can do that. So how to specify the event? So start with the indicator called event, and then give it the event name. Pay attention to the naming convention. And then you have the event parameters, which is you can pass on. Kind of like you design a message template or notification message template, and then this is our placeholder, right? So you just using the syntax to describe it. And this is how you fire that event, which is called raise the event, fire the event, notify the event. It's mean the same, and it's called emit. So Ethereum Solidity using this syntax, maybe other programming language using other syntax, right? So but semantically, it's called, hey, I raise my flag, I send my notification. That's how that works. Okay, so let's see how we can declare event. So our job is to, inside of that, we have to say, hey, new zombie is created. So we have to do, we have to first declare the event. So we have to say event, and we have to say event name, new zombie. It takes 2 parameters. Or 3 parameters. Okay. So it just let people know new zombie is created. Here's a new zombie ID. Here's a new zombie name and DNA. Okay. So once you created this event, let's make sure the syntax is good. Okay. Then we say, how do we in the place to actually call it? So inside of here, you have to call emit, right? So first, he wants us to modify this function to fire this event. After this, so we just do this. Emit new zombie event by giving the parameter. Remember the ID? So somehow we need to have an ID, right? So how do we get ID? So we don't know that yet. So let's just put ID at this moment, but we know how to put a name. Okay. But we need to figure out how do we get the ID. So this is a step how you get ID. So when you push into the array, remember array is like having index, right? 0, 1, 2, 3, 4, 5, 6, like kind of like that. So whenever you call the push, it actually returns the value, which is the index. What is the current index of the array? Because you may already add a 5, you may already add this 10. So whenever you finish this call, it will let you know the length, how many things totally in the array. And if you do -1, and then the question is why we need to do -1, right? Is because array in the computer science typically start with 0. So they start with the 0. So if this tells me that the total length of the array is 5 elements already in the array, and then you have to -1, which is you kind of get the last, the index for the last element, which is what they said that it's the index of the zombie we just added. Okay. So in this particular case, we need to get that array. So that's how we're going to do it. So he wants us to store the result of this into the unt called ID. Okay, all right, let's do that. So we can say unt ID equal to this, right? Equal to this -1. But we already have a line here, so we just have to copy this way like this. So this is called assignment, left and right. So you have this push. You want to push -1. All right, that's how you get an ID. So you can see this line of the code actually combines 3 operations. It combines the operation how to create a zombie element or object, and then it chain with another operation called push, and then it used that to do a math, which is the index -1, so that you can do the assignment back to ID, right? So it's a 1 line actually represents 3 lines over here. So that's why it's a little bit harder to read, but once you kind of understand it, the more time you program and then read it, you kind of appreciate this concise representation here. I did it. That's amazing. By the way, I have to practice this many times, so that's why we can go through this course with you guys smoothly. Okay, so we come to the end of that. Okay, this is the last knowledge we want to share with you, which is called Web3.js. So Web3.js, okay, remember the diagram I just showed you? You have this front end, which is typically HTML, JavaScript, those stuff. And then you have the smart contract logic, which is we just coded in the Solidity. And then later on, we're going to deploy that into Ethereum. But what's in the middle to connect them, right? That is called Web3.js. So Web3.js is a special JavaScript library which is know how to interact with the Web3. So in this particular case, somebody else already created a library for us. So we just simply using a library, we can successfully refer to all of the contracts we just created. Okay. So in today's session, we don't deep dive on that, but I think will be intermediate developers, because intermediate developers they have to actually play with the front end codes and actually hook up with the blockchain involving end to end. Okay, but in the CryptoZombie, you can read it by your own and then see how they actually using the Web3 library, and then somehow you can get the variable about the contract you just created. Once you get a contract variable, and then you can trigger the contract, right? Like right here. This is how you trigger the contract in the front end code. And that's how everything kinds of tail together or connect together. And then you can also get the event. Remember the event, new zombie event? So it can also return back to the front end, and then you can show them nicely about the UI. Okay, so we have successfully built a zombie factory with one random generation to create a zombie, right? So in this particular UI, they asked us to give the name. So I'm gonna give the name Hui. Oh, looks not good, but that's okay. And then hit the enter. Yeah, it already automatically give me the appearance, right? So if I gave Hui 2, okay, go back to Hui 1. Yeah, okay, I get it. All right, we have successfully finished the pack 1. Okay, let's give a 1-minute break. I'm gonna go back to the chat to see is there anybody have a question before we dive into pack 2 in another 30 minutes. So hopefully we can close our today in 10. When we create a zombies with ID, where are they stored? Okay, that's a question. I will answer that, Frederick. Why do you create an event on line 5 in the beginning? Okay, Victoria, I'm going to answer that question. Okay, okay, so let me go back to the code. Event, right? What's the first question? Sorry. When we create, sorry, this one. Why do you create an event on the line 5? Okay, cool. Okay, the reason to have this is you have to specify event signature first. Kind of like you have to specify the function signature first before you can call the event, right? So there is a signature and then there is actually call the event. So you have to do twice. So this is a signature is tell the compiler. So say, hey, I just wanted to specify how that look like, but I'm not going to call it because the calling thing can be outside or it can be any function, right? You can specify it without calling the event at all. You can do that. So that's why number 5, you have to specify it. So this is a so for us human, you know, we're like very intuitive, right? When we see it, we just like mix them with that. But for machine, you kind of have to describe it. You have to describe its functionality, and then you can have to code it, the interaction. So there's a 2 important logics here. That's why you have to code the event. Okay, why we need to create a zombie with ID? Oh, when we create a zombie with IDs, and where are they stored? Great question. So, okay, let me just write some notes here to help us understand it, okay? When we say ID, don't think about the ID as a identifier, like credit card number, your social security number. So it's not like that, okay? You can design like that, but in this particular course, the ID means the index inside of the index for the array. Okay, so remember the array. Okay, array has a concept called index. So that means 1, 0, 1, 2, 3, 4, right? So it's just like integer. Okay, so when you call the push function, it will automatically return the length, right? So if you call this function first time, it will return 1 because you already put a 1 element inside of the array. If you call this function twice, it will return 2 because you already have 2 elements inside of the array. Okay, so in order to refer the first one, the index for the first one is called 0. The index for the second one is called 1. Index for the third one is called 2. That's how you refer each element. Okay, so if I'm using the syntax to refer that, so basically you can say, hey, zombies, please get me my first zombie, right? So if you specify it like this, which really means that the ID of the first one is 0. That's what they said the ID over here. Okay, so they're using very simple meaning to represent the zombie ID, which is just the index is integer. Kind of like you put in the spreadsheet, right? And then you have a column called index. That's it. That's for that ID. Okay, no problem, Victoria. Thank you coming. Okay, hi. Okay, cool. Now let's move fast. We're gonna go to a different course now. Okay, so we're gonna go into lesson 2. All right. So before we go to lesson 2, let's see what the lesson 2's goals, right? Business goals here. Remember, we're gonna add a complexity. We already create a very simple zombie factory contract. So here we said that when a zombie can do something, right? Zombie can bite others. So it's called zombie feeds. So when zombie feeds, it can turn the affected host into a new zombie. That makes sense. So the idea here is we have to simulate this. So how a zombie meet with another zombie, and somehow you have to create a new zombie, because it can somehow generate a new DNA, and then which is a new zombie created. And the game here is because you attack this victim and you gain something, right? What you gain? You gain your zombie army because you wanna the battle in your side can win, right? The second one is one person can hold multiple zombies now. That makes sense because before one person can create a zombie, but how do I make sure I have a data structure or maybe some bookkeeping that tells me that here's a Hui zombie, Hui owns. Here's a Victoria zombie, Victoria owns, right? So we need to figure out how to model that. And the third requirement here is user can't create unlimited zombies. So we have to somehow change our logic to say that it's a default 1 per user. The last is we also want to show special appearance for a cat zombie. So now we'll introduce a new case, which is when zombie trying to attack a cat, and somehow we wanted to say, hey, a special cat zombie is born. That's the whole 4 challenges we're going to go through this course in the lesson 2. Okay, so with that context, we can go through this very quickly, right? You already understand the zombie feeding. If you don't, just read the message over here. So the idea here is right here, me, and then this. So if I try to attack that, right, say, hey, I'm going to attack this. See? It says a newborn zombie generated. This is a mine, this is the other, and this is a new one, and this is the affected one, right? So those how the new kind of a graphical way to let you know what we're trying to achieve here. Okay. Remember, we need to somehow have a more data structure so that we can store some more information. So far, we only have a 1, right? So here's all of the zombies created by the system, created using the zombie factory. But we don't have any data structure to tell that this is a Hui zombie, this is a Victoria zombie, right? So we have to declare that. So right here, we're learning 2 new data types called mapping and called address. So first, we talk about address. Address, if you're already familiar with blockchain, you kind of get it. So address is just like it's a first class concept, which is people can store the assets, which is cryptocurrency. Also, contract can be deployed on the Ethereum, and the contract has address as well. So when we say contract on the Ethereum, we really mean two possible things here. Okay, so then let's talk about mapping, right? So the way we said that this is a Hui zombie, this is a Victoria zombie, is not to store Hui's name. Of course, you can model that. But in this particular case, we wanted to say that the asset that belongs to the Hui's address, right? Because the address represents another identifier, which is for Hui, which is account. Okay, so address is very important concept in Ethereum because it doesn't have any identity related information to refer that, but the address is the one say because you have the private key, which is prove that you are the owner of that account, of that address. Okay, back to here. Now we say, what is the mapping, right? Remember, we need to say, our goal is to come up with the structure so we can have the data stored in this site, in this contract. So mapping, think about mapping as a Excel with the two columns, key and the value. Column 1, column 2. Okay, like a dictionary, you can think about that too as well. So in this particular example, you can see that we can have a column 1 called address. We said that for this address, here's a lookup value called another column called uint, which is data type, right? So you say another integer, which is you can hold the account balance. So all it says that this is a mapping data structure, which has a key and it has a value when you do the lookup. Same thing here, right? User ID to name. That's how you describe it as a mapping structure. So come over here. Our job is to create a mapping structure called zombie to owner. So the idea here is, given a zombie ID, how do I know owner? That will be this mapping structure trying to achieve. So what we need to do here is just simply follow that mapping, specify the two columns or data types, which is uint, kind of represent its integer, because right now zombie ID is an integer, and then we say owner map to the address, right? So that's how you declare this mapping. So they also asked us to do another mapping. So this mapping is called owner zombie count. So the idea here is, given the address of the owner, can you help me to return a zombie count? Okay, let's build this two columns spreadsheet or dictionary, whatever you want to call it. So you say address, and then count, right? You want to return a count like 3 and 5, 10, so that will be integer. And then you say owner zombie count. Okay, so far we have learned how to do mapping. We also learned what is address mean, and then here's a syntax about declare a mapping structure. Any question? This is a little bit advanced topic. Okay, no. All right, let's move on. We have some syntax error. Let's see. We're missing probably public, right? Okay, let's do public. So you can see here is anytime you specify the public, you let the outsider know you actually can access to this, either the structure or the function. That's how you specify the public. That work. Okay, so in this, we're going to continue on this in this chapter, right? All right, so the first thing we're going to learn is called message.sender. So what is a message.sender? Very simple. Message.sender is an Ethereum kind of a convention, right? Whenever you use message.sender, it can actually refer to the caller, the person who calls the current function. Okay, so that's a message.sender trying to do. Okay, let's see what the exercise we wanted to do for the message.sender. So they want us in this create a zombie private function. We already got an ID, right? And then the goal here is to update this mapping by storing the caller, which is the message.sender. Okay, so idea here is we know how to create a zombie, but we don't know how to let people know who is the one calling that, right? Who is the one create this zombie, and then so that we can bookkeep it into our owners table. That's the goal. So what we need to do here is to somehow, you can see here, we need to add that. So the idea is to specify, this is how we assign the value to the mapping, okay? So we need to assign the value to this mapping structure. We need to say that, hey, for this ID, you just get it, please assign this variable called message.sender because that will be the owner, right? So that's how that works. So once you have done that, and then they also want you to increase the UNT with ++. Okay? Okay, so this is what is the ++? ++ is just like an incremental operation. That means if you have an integer variable called number, and then if you do this operation, it will automatically like increment by 1, which is number become 1 now, right? So that's how this syntax actually works. So what we need to do here is let's increase the count for this messenger. We have two structures. We need to somehow interact with this two structure. So that's what we need to do. We said that, hey, under this, for this particular address, we wanted to increase one variable, right? So what we does here is to say, hey, message.sender, which is that's how we refer to that particular owner. And then we should be able to get the count, okay? We said that for this count, we want to automatically create it by 1. That's how that works. Okay, so let me read this again for you guys. Just make sure you kind of grasp it on this. In here, we add these 2 line codes. We know how to create a zombie. We know how to get their ID. But our goal is to interact with these 2 structures so that we can store them properly. One is to store the mapping between the ID and the owner. This is this line, how to achieve it. Another is to store the ID, address, owner, and then say, hey, what is your current zombie count? You have it. And this is this line to achieve. Okay? So if this is very new to you, you just take some time to digest that, okay? But for most of the people who understand, programming before this, it's easy to grasp it. Okay, move on. Now in this chapter, we're going to introduce a concept called require. So what is require? We're learning a lot of the syntax today, huh? So require, think about the require as kind of like Excel has this validation, right? You can actually assign data validation rules, make sure you only can choose certain value out of the job box. So require kind of like that. So you basically said that, hey, I want you to evaluate certain things. So think about this, a Boolean, think about some conditions, you can evaluate it. And then when you put a require and wrap it, it says that you must satisfy this condition before you move on. That's about it, okay? So in this particular case, they want us to make sure we can achieve one business requirement. Let's see what we want to achieve. So the issue about this function, if you look at this function, right? That means if somehow I can call this function, I can call multiple times. Like outsider caller, maybe call this create a zombie, create a random zombie because this is public. And this public gonna turn around to call this whatever the create a zombie, internal private function, right? So in theory, I can call this create a random zombie function unlimited. So that's why they said that, it won't work if you allow the user to create unlimited zombies, right? It doesn't make sense. So how do we put a limitation on that? So in order to put a limitation, they want to make sure only the first time, if you're the caller called the first time, and then you can continue. If you call multiple times, you cannot continue. That's what we do. So we're gonna put the require. We said that, hey, please require. We're gonna check you, right? We said that, hey, how many zombie you already have it. So we do the lookup by passing the caller address. Using this caller address, somehow we go to the table, and then we recognize that, oh, you only called before, you only have 0, right? Or you already have 1. So if you have 0, you pass it. You can continue on the rest. If you already have a 1, that means you'll fail this condition, because 1 does not equal to 0. You'll fail it. And this require syntax basically just automatically return these functions. It does not trigger the rest of the logics. So that is how require actually work. Okay. Yep, that makes sense now. Okay, now we're going to talk about fancy stuff called inheritance. Okay, so look at our zombie class. We write a pretty 35, 40 lines code, right? We can continue adding that. So basically, one file of Solidity file, you can have many contracts as you want, but it will not be readable, right? So it's hard for other developers to understand it, and even for you to debug on that. So the idea here is to move around those contracts, organize them. So that's why sometimes we will put a certain logic in one contract. For example, right here, they put a certain logic in one contract, and then they put other logic in another contract. And then one of the contract-to-contract relationship is called inheritance. So what it does here is say, hey, I have a new contract called B. The B is like baby Doge, is actually is Doge, right? So you just say that, hey, I want to automatically inherit all of the contract in my whatever this parents, so that I can add an additional contract in my baby Doge, because I want to do some fun stuff. So that's how you do it. So in our particular case, they want us to introduce a new contract called zombie fitting. Okay, so that's what we're going to do here. So say contract zombie fitting is zombie factory. So all it does is, hey, I'm a child contract. I'm going to inherit from my parents. Okay, and then that should work. Yeah. Okay, so then right here, you can see that there's 2 files have been created nicely for you. So that's why we move this, we move another contract and then rename it as a new file. And then this is our zombie factory, which is only contain 1 contract. So that's good. So typically, programmers will organize their codes around like 1 contract per file. That will be easy for them to find the right contract and then work on it. So because we're putting a zombie factory in another file, so how do we let this thing to kind of to find it, right? Because without the compiler have to know something so that they can discover it. So if you just read this code, nothing I can discover about where is my zombie factory. So that's why the import is useful here. So let's just say, what does that mean? Okay, so you put an import, you say, hey, please import another file, right? So this is just like syntax about the current location / which is kind of like indicate that where can I find the files, and then you give the file name. If you specify this, the compiler will say, okay, I'm going to go through if I cannot find the contract within my current file, I'm going to try searching an other file. That's how that works. Okay, so we need to do that to refer to that because we already created 2 separate files. So you say ./zombiefactory.sol. Remember, semicolon. Okay, that worked. Okay, so now let's continue on building up zombie feeding logic. So inside of the zombie feeding, right, before we do that, there's a very important concept called storage and memory. Because in Solidity, everything requires gas. There's a different infrastructure. It's not your local computer. You own it. You can run it. It's kind of like a rented computer, rented data storage, right? You have to pay the miners, and then they're the one. So if the contract gonna deploy on the Ethereum, certain operation in order to interact with that contract require gas. So one area is called the storage of data. So that's why the storage gonna permanently store your variables on the blockchain, but memory just the temporary, right? So somehow Ethereum protocol, or maybe the whatever the protocol libraries will differentiate it whether you are the storage variables or memory variables, and that's how they determine if you need an actual data storage, you need to pay the gas. Okay, so they also talk about another interesting thing, that is where is it? Okay, yeah. Sometimes if you have a struct with the multiple variables, and then you can look at the data type, which is that helps you to save certain storage, because sometimes you don't need that, right? So we come back to that structure, how to efficiently declare the right structure, which is maximize your gas, saving the gas, goal. But for right now, right here, you just need to understand it. When I need to deal with the data, I have 2 options. I can tell the Ethereum to store it, or I don't. Okay. So right here, we need to create a function. So let's create a function. Called feed and multiply. Okay, and we'll take 2 parameters. Let's just follow that, and I will explain now what does that mean, okay? And then you have uint, target DNA. So you take parameter, and then you specify the public. Okay, we got it. So remember the business requirement. One zombie can attack another zombie, another host, which is somehow generate a third one, right? So that is our goal. So okay, so next they want to make sure we do the same thing by adding a requirement. Not everyone can call it. We must say that make sure we own the zombie, and then you can call it, right? So we need to put this function here. Require is always like trying to evaluate that. Whatever things you put inside of that, they evaluate it. So we said that we want to evaluate message.sender that is equal to the owner of the zombie. Remember, we passed the ID. So we have to do the lookup, right? Because we do are you the same address of the caller address? That's what we ask. So we have to go here, because this is the table help me to go from the ID to address. So we go to the lookup table, and we said that if I'm gonna pass you zombie ID, please return that address for me. And if the address is the same as the caller, that means you can continue the rest of the logic. That's the requirement. Okay. And then the next is we're going need to get this zombie DNA, right? So that's how we do it. So we're gonna call zombie, my zombie. So we're declaring a variable for that. And then they want us to use this to be a storage pointer, okay? So set this variable to be equal to the index of that, right? So we need to go to the array list to fetch the zombie by index, okay? So here's our array list. We're using this to fetch it. Now we get this right zombie element. So that's what we have so far. Oh, we definitely have a more thing to do in this function, but right now that's two lines of code, which allows me to fetch the zombie I belong, right? Okay, so let's check it. Okay, we have some issues. Okay, so let's see what happened. Do we need to mention about storage? Because we want to permanently store it. Is that the right syntax to store the storage? Yes. Okay. Yep, that worked. Okay, let me see any questions. Okay, no. All right, let's move on. So here, we have 10 minutes, so we have to go fast. So zombie DNA, okay? So let's finish writing up. So in this particular case, we wanted to use a simple math to come up with a third zombie DNA. The way how we do that is to say, hey, what is the one you try which is the zombie you own, and what is the one you're attacked, and then we're going to use this average math to come up with the third zombie DNA. Okay, so that would be the requirement over here. So the way how we do it is this. First, we need to make sure it's in the long net, okay? Yes, because that's our parameter. So we just simply do this as what the instructor says. This is kind of a guarantee. You have a 16-digit of your target, whatever you attacked, right? So the target means what you attacked. And then next function, we wanted to generate a new, which is the third one. Okay, so you say new DNA equal to the math, right? Average of the mine and the target one. So this is how we do it. We use the myZombie.DNA, which is we can access our DNA variables, and then we set that plus, right? So we're gonna do math my target DNA and then divide it by 2. That way you get a new. Once you get a new, we have to create a new. We just got a DNA, but we haven't created it yet, right? So I have to call the function to create it. The way to create it, because we already have a zombie factory, we can go over here to call functions. So the way we call it is this, called create a zombie. Okay, so that's how you over here you can actually trigger that. So we're gonna call create a zombie by giving the parameters that match the signature. So the signature is called name and DNA, right? So for right now, we don't know the name, which is the third zombie name, but we just simply gave the no name at the beginning. And then you just simply put DNA. Okay? That's how you successfully create a zombie in here. Yay, we did it. All right, so there are more on the function visibility. That's the place I'm going to talk about internal and external. So you're already familiar with public, you're already familiar with private. Now let's look at the 2 additional things called internal and external. Okay, So internal is same as the private, except that it's only accessible to the contract that inherits from the contract. Okay. So the idea here is we're introducing sub-concept, right? Like this is the inherited contract, which is can borrow or inherits all of the functions and variables from the base. So over here, you can actually change the private to internal so that your inherited, you basically let people know that if anyone wanted to inherit my contract, you can also call those contracts, the functions. So we need to change this private into the internal so that another contract can actually trigger that. Okay. External is similar to public. Only difference here is except those functions can only be called outside of the contract. They cannot be called by other functions inside of the contract. So think about this external as like exclusive, I want public to be called. I want it only exposed to outside, right? You don't want it to, it's a similar except that those functions can only be called, only be called outside. It's exclusive to be called by outside, not by inside. So that's internal and external. Okay. I do have some notes here, which is help people to understand that the relationship, the calling scopes. So if you have a contract and then you have what are the functions you can call inside of the contract scope? If the contract B is a subcontract inherits from A, what are the things you can call for the B itself, and then what are the contract you can inherit call from A? Same thing for outsider, right? So this kind of let you know the scope of the functions, which is you need to think the right policies for the right function visibility. Okay. So in this particular case, we need to change the private to internal, which is we just did it. And then we can continue, sounds like. Yeah, we continue. Okay. All right, in here, we already got the feed and the multiply, right? It's pretty big. 6 lines of codes, but 5 or 6 lines of codes, but it's important to understand the logic. So now we need to do the last requirement, because we want to have a special fitting, which is now your attack. What you attack a cat now, because you want to create a cat zombie as a newborn, right? So this is how we do it. Okay. We only have a zombie, but we don't have a cat, so a kitty. So we need to assume that there will be some kitty contract somewhere or kitty factory somewhere, right? So assume that you have a kitty factory, but in order to refer to kitty, you have to specify something called interface. Okay, so in this particular case, we're going to declare a kitty interface over here. And then you can see the way we do that, it's very similar to contract, but just without the body, right? We just simply say that it's an interface. And I'll show you how to do that right here. So look like this. So you start with the contract, and then you put the interface like this. Okay. So you say, hey, it's a kitty interface. And then what we want to do is just simply refer to a function signature, but without specify the whole logic about that function, because it's an interface, right? Interface is about just like help the other side, to see your how I should interact with your functions. Okay. So here we need to define the functions. So we can simply call this one. This is how we do it, right? We call this function, okay? Because we don't want to specify the details of the function, so we just simply put an and over here. So you can see an interface contract, just simply a list of the function signatures like this. Okay. All right. Let's see. Whether this work or not. Yay, that worked. Cool. Any questions about interface? Oh, thank you, Varsha. I'm trying my best. Okay. Now you declare interface. Okay. Think about interface as a mini contract without specifying how to do it. Just specify what it looks like. Now we need to use it, right? It's always like this: specify, use it, as a two different scenarios. You have to think about it. Okay. Come back here. Inside of the zombie fitting, we need to have we need to create a logic. Then we can work with, we can generate the kitty zombie, right? That would be the special zombie. We're gonna create it by attacking kitty. So this is how we do it. Okay, so they said that is we're gonna introduce our address. Okay, so this is how you specify address. Okay, so we wanted to use this address variable to indicate the kitty contract address, which is just mentioned about above, right? So let's see how we achieve it. What we do here, we just new it up. Okay, this is how we do it. So we said that. I think we just go ahead and replace this. Maybe I keep that. Okay, let's just say that ck address by new it up, right? So we just simply call that kitty. Let's just try it to see whether that work or not. Interface, just like what we did in the num contract. Okay, let's see what the num contract did. Aha, that's how you refer that. Okay, so you have to introduce because we want to use the kitty contract, so we have to do like this. So what you need to do is we said that kitty interface, which is the mini version of the contract, and then we said that kitty interface equal to construct, right? We want to construct it, and then we just pass that address, and then we have to make sure we passed. Here's the address. Okay, is that what they asked for? Yeah, under the variable, save the address. Okay, then we have to call it. All right, let's see whether that worked or not. Okay, it didn't work. Oh yeah, the variable is different. So I have to use their suggested variable. That makes sense now. That should work. All right, we get it. Okay, so now we successfully in a zombie feeding contract to refer to another contract by using the interface idea. Okay. So now we have to handle multiple variables. So in this particular course over here, the returns can have multiple returns, right? You can return multiple things, which is you can do that. So you can actually do so here's a trick. The trick here is if you have a function that can return multiple variables as a return, the whole return set, you can actually call the function, which is you call this function, right? And in your left side, you can do one line code, and then automatically assign to the right spot, okay? Because you have a multi-assignments going on. You can also, like using this syntax, which is you basically say that I'm not interested in others, but I'm only interested in the last one. So you only care about the last assignment. So that is how you deal with the multi-returns and then multi-assignments. Okay, so let's see what exactly we try to achieve here. Make a function called this. Feed on kitty. Yeah, that's our goal. And then we say uint. Okay, we say take two parameters, right? Okay, zombie ID. Another one. Kitty ID. Make that as a public. Got it. No big deal for the signature. The function should declare you as a name the kitty DNA. Okay. All right. So inside of that, right, we need to like uint kitty DNA. Let's just leave there for a moment. The function should then call the get kitty. Okay. You want to get kitty. Okay. With the kitty ID you just passed. Okay. And then remember the get kitty. The get kitty is multi-return, right? So we want to have multi-assignment in this case, but we only care about the last one. And then they said that they already count for you. There's a 10 parameter in this multi-returns, but we only interested in the last one. Okay, so this is how we achieve return. So what we want here is first 1, 2, 3, 4, 5, 6, 7, 8, 9, last one. We say the last one, we want you to only assign that to that kitty DNA we just declared, right? So call this function, which is have a multi-return, and then using the syntax, which is multi-assignment. That's how that works. So now we successfully get a kitty DNA through this get kitty function contract. Finally, we wanted to pass on this because we have this generic function, which is one zombie attacked another case, and then so we just call that generic one, right? So this is a special one, this is a generic one. So just call that generic one. Make sure your parameter always aligned. And then target DNA, which is kitty. Oh, poor kitty. We're gonna target on you and generate the zombie. Sounds good now. It looks like we did it. Yeah, amazing. All right, we're almost done, okay? So our function logic is complete. If you already come so far right here, the last thing they want to teach you is called if statement, which is kind of an if then else. It's very simple to understand it. So you start with the if, and then you use the parentheses, and then put in your condition inside of that, and then you can have whatever that condition is true, you go through the certain logic. If the condition is not true, you'll never execute that logic, right? So that's what we need to do over here to add a little bit of sophistication. So first, let's change the function definition so that it can take third parameter. Got it. So right here, we need to take third parameter. Third parameter is a string, memory, underscore species. Okay. The second one says that is after you calculate the new zombie DNA, which is new zombie DNA right here, let's add an if statement. Right. So they want us to say, hey, if, right? If what? if your target, if somehow your species, which is the third parameter which you're trying to attack, is kitty, okay, that's the condition we want to evaluate. This is a little bit weird thing going on for the Solidity, okay? In other programming language, compare string to string is very simple, right? You just like string A equal to string B equal to string B, you can compare it. But on Solidity, this is the comment here. Compare a string on Solidity requires gas. So you have to figure out a smart way to compare the string, okay? So you cannot simply say that whether my sandwich equal to BLT in the most of the simple Python or other languages, but here you have to like take a little bit another twist here, which is you call the hash function, which is more efficient, and then you compare string equal whether equal or not. I still need to find the evidence why we need to do this dance, okay? But that seems to be like way different, like how other programming handle that to just simply compare strings. But for this sake, we have to compare string using this way, okay? So the idea to compare string is just like do this, okay? So we're gonna copy like this. And we said that we wanted to compare what, right? We compare the species, whether equal to the same thing, which is another case is you hard-coded with kitty. So the idea is very simple. I want to compare the variable, whether it's kitty or not. But we have to write the code like this on Solidity. Okay. Then if the statement is true, because we wanted to add a little bit fancy about appearance of this cat zombie we just created, right? So that's how you twist a little bit DNA. So the idea here is we want to use this math, okay? And then what is math? The math says that you already have a new DNA, but I want to do one more thing about that new DNA. I want to replace the last two digits. So for example, your new DNA is this. I want to somehow replace the last two digits with always 99, right? That's this math help you to do that. Okay. So once you have this, then you basically give that cat DNA always another twist. Okay. Make sure I have a parameter correct. Okay, correct. So we need to change the function call, and then okay, got it. So right here they're saying that because we add a third parameter, right? So we have to pass on that third parameter with actually kitty. So now we're fully connected. You see? Okay. Wow, I did it. So that's how you do this third parameter by introducing if statement. Let me go back to here. Insane. That is insane. True. Even we're just trying to create a simple game called CryptoZombie, right? Okay, finally we can play with that. By the way, because we have not gone through front-end code. So this is a front-end code, which is somehow later on, once you do the user interaction, it will call the smart contract, right? So let's see. You want to attack this cat. So you say, hey, I'm going to attack this cat. And then once you attacked it, please generate the CryptoZombie, right? That's the whole idea. Let's do it. Voila. So here's a new cat zombie generated, which is, here's so I need to put my name there, okay? and this is CryptoKitty DNA, and then this is the new zombie DNA. Let's try another one. I haven't given my name, right? So anyway, so it doesn't have a text box to assign my name. It should say Hui's, Hui zombie over here. Okay, let's try this Q1. Yeah, got a different one. All right. Okay, that's the pack 2 of CryptoZombie class. We finally finished this today, and I hope you're enjoying this session. We will continue on next Saturday, which is we're gonna go through next 2 called Advanced Solidity Concepts, and then introduce another sophistication of the system called Zombie Battle System. And then after the 3rd week, we're going to tackle how does the ERC721 NFT, and finally we get a little bit taste about front end. All right, so hope you enjoyed today's dev CryptoZombie walkthrough, and then you have an amazing day, and we see you on next Saturday. And don't forget to subscribe my dev channel. And then I just made up, last week, because a lot of the women want to get into the blockchain domain. And then I believe we can all become Skylight developers. All right, see you on next Saturday. Bye-bye. I forgot to mention about you need to do the homework, but if I probably already stopped it. That's okay. Let me stop the